Hello, viewers. In today's session, we are going to discuss some important problems from differentiation involving inverse trigonometric functions, right? And here we have the first problem where we have to differentiate this function tan inverse, and we have square root of 1 plus x square minus 1 over x, where x is not equal to 0, right? So let us see how we can find out the derivative of this function using some identities from trigonometry, right? So to get the derivative of this function, we'll first make use of some appropriate substitutions so that we can simplify this function, that is square root of 1 plus x square minus 1 over x, right? So here we'll first take this function as y, and let us make an appropriate substitution here, and let us take x is equal to tan theta, right? So the purpose of taking x is equal to tangent theta is that here we'll get an identity when we substitute x is equal to tan theta, right? So we have now y is equal to tan inverse, and here we have square root of 1 plus tan square theta, and then we have minus 1 divided by tangent theta, right? Now from trigonometry we know that 1 plus tan square theta is equal to a secant square theta, right? So this is an important identity, and the square root of 1 plus tan square theta is given by square root of secant square theta, that is simply a secant theta. So now we have tan inverse, and here for square root of 1 plus tan square theta we can now take secant theta minus 1 over tan theta. Now let us simplify it further. So we can now write tan inverse, and for secant theta we can now write 1 over cosine theta and minus 1 over sine theta over cosine theta. So now we have expressed this expression in terms of sine theta and cosine theta. So taking secant theta as 1 over cosine theta and tan theta as sine theta over cosine theta. So now we can write tan inverse, and we have 1 minus cosine theta. So multiplying this 1 by cosine theta, and here we have cosine theta divided by sine theta over cosine theta. So now we have this expression. Now cosine theta and cosine theta get cancelled, and we have tan inverse, and here we have 1 minus cosine theta divided by sine theta. Now once again we'll make use of uh, some important results from trigonometry. So 1 minus cosine theta can be written as 2 times sine square theta over 2, right? And sine theta can be replaced by 2 times sine theta over 2, and here we have cosine theta over 2. So now this function y, it takes the form tan inverse, and 1 minus cosine theta can be written as 2 sine square theta over 2, and for sine theta we have 2 sine theta over 2 and cosine theta over 2. So now we can cancel this 2, and here we can cancel sine theta by 2, and we have now a tan inverse, and we are left with sine theta over 2 divided by cosine theta over 2. So now we can write tan inverse and sine theta over 2 divided by cosine theta by 2 is simply a tan theta over 2, right? So now from inverse trigonometric functions, we know that tan inverse tan say x is equal to x, right? So here x is theta over 2. So here we have simply theta over 2. So now our function y in terms of theta is equal to half theta. Now from this substitution, we have x is equal to tangent theta. So theta can be replaced by tan inverse x, right? So taking theta is equal to tan inverse x over here, we have now y is equal to half and tan inverse x, right? So by making this substitution, we have now simplified this function as y is equal to half tan inverse x. So this function and this function both are same, right? So now we can differentiate y with respect to x. So taking the derivative, so we have dy over dx is equal to half and d by dx of tan inverse x. And we know that the derivative of tan inverse x is given by 1 over 1 plus x square, right? So the derivative of this function with respect to x is given by dy over dx is equal to 1 over 2 times 1 plus x square, where x is not equal to 0. So this is the required derivative. So now consider this function. So here we have to differentiate tan inverse 1 minus cosine x divided by sine x with respect to x when this condition is given. That is x is greater than minus pi and x is less than pi, right? So let us take this function as y, right? Now here we are given 1 minus cosine x and here we have sine x. So let us directly make use of the identities, that is 1 minus cosine x is given by 2 sine square x over 2, and for sine x we can now write here 2 sine x over 2 and cosine x over 2. So now this function y, it takes the form that is tan inverse, and here for 1 minus cos x we can now write 2 sine square x over 2, and for sine x we can now write here a 2 sine x over 2 and cosine x over 2. So now here 2 and 2 get cancelled, here sine x by 2 and sine x by 2 get cancelled. So we have tan inverse, and here we are left with sine x over 2, and here we have cosine x over 2. So now we have tan inverse, and here sine x by 2 divided by cosine x over 2 is simply a tan x over 2, right? So now the function y is it can be expressed like this. Now using an important property from inverse trigonometric functions, we know that a tan inverse of tan say theta is equal to theta, provided this theta belongs to the interval minus pi by 2 to pi by 2, right? And here we have exactly the same form. Here we have tan inverse tan x over 2, here we have tan inverse tan theta. So for theta we have x over 2, right? So now we can write this expression as simply x over 2 using this result, provided theta belongs to this interval. So here theta is x over 2. Now let us come to this inequality or the given condition. Now see, we are given x greater than minus pi but less than pi, right? So if we divide throughout by 2, so that we can get x over 2. So here we have minus pi over 2 and x over 2, and here we have pi over 2. Now this inequality suggests that this x over 2, it belongs to this interval, right? So we can write tan inverse tan x over 2 is equal to x over 2 due to this identity, right? So now we have y is equal to simply x over 2. Now let us differentiate both sides with respect to x, because we have now simplified this expression using these two identities as y is equal to x over 2. So dy over dx is equal to d by dx of x over 2. So this is half, and this is d by dx of x, and the derivative of x with respect to x is 1. So here we have half times 1, that is equal to half. So the required derivative of this function is equal to half.